Hi friends, in this episode we'll see about the water treatment plant in which how the DM water is produced. Ion exchange is a chemical reaction which is reversible. Demineralized water is produced by passing filtered water through strong acid cation SAC, weak base anion WBA, degasser unit, and then strong base anion SBA. SAC resin type is sulfonated polystyrene and the color is golden yellow. The density of the SAC resin is 1.3 to 1.4 gram per cc and resin form is RH plus. The H plus ions which are present in the bed are replaceable ions. The cations calcium, magnesium and sodium and rarely potassium are getting removed in the SAC bed during the service. The H plus ion will be replaced by calcium and magnesium and sodium. This will go unattached with the resin and H will combine to form with a chloride, sulfates and bicarbonate to form weak acids. The total dissolved solids or the minerals present in filtered water is categorized as calcium chloride, magnesium chloride, sodium chloride, calcium sulfate, magnesium sulfate, sodium sulfate, calcium bicarbonate, magnesium bicarbonate, sodium silicate, and calcium phosphate. It gets exchanged with RH plus ion, which is SAC resin present in the bed. Calcium chloride, magnesium chloride, and sodium chloride will react with the resin and get exchanged with the RH plus ion to form R2CA, R2Mg, and RNA. The anion side will form with the H plus ion to form HCl, weak hydrochloric acid. Same sulfate and of calcium and magnesium and sodium will react with the resin. The H plus ion will be replaced by calcium, magnesium, and sodium, and weak sulfuric acid is formed. Calcium bicarbonate and magnesium bicarbonate react with the resin. Calcium and magnesium will attach with the resin. Weak carbonic acid is formed. Same like sodium bicarbonate react with the resin to form weak carbonic acid. Sodium silicate, normally silica is present in the form of sodium silicate only. That will get react with the resin to form H2SiO3, weak silicic acid, and phosphate as calcium phosphate will get attached to the resin and weak phosphoric acid is formed. This is a service reaction and the cationic water will be containing weak hydrochloric acid, weak sulfuric acid, weak carbonic acid, weak silicic acid and weak phosphoric acid. The SAC buttyl crosses the value or the equine mineral acidity EMA and free mineral acidity FMA difference is greater than 10 ppm. Then the SAC unit is considered as exhausted and it will be taken for regeneration. SAC regeneration is done either by co-current method or by counter-current method. Co-current method is same as service. Service is top to bottom, also the acid injection is from top to bottom. And in the co-current method, first step is backwash, followed by acid injection. If it is HCl, 5% acid is used, and for sulfuric acid, 3 to 3.5% acid is used. Then the final step is the final rinse. During the final rinse outlet, the water is checked for EMA and FMA. That is, EMA is equal to FMA or FMA is equal to service FMA, but value, then regeneration should be considered as completed and it should be stopped. Also, we can check total hardness, which should be 0. In the counter current method, normally which is opposite to the service. Service is from top to bottom and counter current method acid injection is from bottom to top. When the acid injection is given from bottom to top, we will have to keep downflow from top to injection header, either with water or with air. Then it should be followed by the final rinse. Once in 5 or once in 7 regeneration, you have to give backwash. It should be followed by double injection and then final rinse. That is every 5th regeneration or every 7th regeneration, we have to give backwash, and then the acid volume is to be doubled. Then after the injection, the final needs to be given. In co-current regeneration, bed top portion is normally regenerated completely compared to the bottom layers. In countercurrent regeneration, bottom layers are regenerated completely. Also, acid consumption is less as regeneration residential time is more than co-current injection, and mainly sodium sweep also is avoided. Even slight slipping of sodium will give high pH and conductivity in SBA outlet treated water, which will lead to caustic embrittlement in boilers. The sodium slip will occur in co-current regeneration. It will not occur in counter-current regeneration. HCl is also preferred over sulfuric acid as regeneration with HCl is more effective than H2SO4. DMA, equal mineral acidity, is checked by passing the filtered water through standard column or pilot column in the laboratory. 100 ml sample is taken and it is mixed. It is added with mixed indicator for FMA 3 to 5 drop. Then the sample will become red. Then it should be titrated against 0.0 to a normality sodium hydroxide. The endpoint is color changes from red to green and the reading is noted. The FMEA value is calculated as reading into 10 ppm. That is the value of the FMEA. And during the regeneration, 5% HCl or 3 to 3.5% S4 is used. If HCl is used, it reacts with the resin, exhausted resin bed during the regeneration, and the R2, Ca, Mg, and Na present in the bed will get replaced by the H plus ion. So the resin will become normalized, is RH, ready for the next service, and the effluent or regenerant outlet is contains calcium chloride, magnesium chloride, and sodium chloride, which will go to drain. If sulfuric acid is used 3 to 3.5%, same the resin bed which is having calcium, magnesium, sodium will get react with the resin to form with the acid to form RH, and sulfate as calcium sulfate, magnesium sulfate, and sodium sulfate goes to drain. The countercurrent regeneration is very effective. It consumes less acid volume, sodium slip is nil, but we need to have some inert resin over the injection header. That is, the resin volume is higher than co-current regeneration, but even we can use contrast ball with density less than water. Density should be around 0.8 to 0.9 gram per cc. This inert media, whether it is resin or contrast ball, it keeps the resin bed intact with downflow of water is used. When acid is injected from bottom, downflow is kept from top inlet line to injection outlet. This arrangement gives more residential time and area of contact is increased, thereby injection is very effective. In the countercurrent regeneration, the inert resin, if there is placed over the injection header, then that will not get regenerated. So during the fifth or seventh regeneration, when the backwash is given, that inert resin will get mixed with the normal exhausted resin. So to regenerate the total volume, we have to use twice the amount of the normal regenerant quantity. Now we can see the comparison between the regenerant used in SAC between hydrochloric acid and sulfuric acid. If the hydrochloric acid is used, then we have to use more volume because the concentration of acid is only 33%. And if sulfuric acid is used, the amount taken for regeneration is less as the acid concentration is 98%. So when you dilute it with sulfuric acid, the total volume used for the regeneration is less compared to hydrochloric acid. But sodium slip will be very negligible, almost nil if hydrochloric acid is used for the SAC generation. If H2SO4 is used, slight sodium slip will be there, which will lead to high pH and conductivity in SPA outlet water. Also, if sodium slip is there, means that will cause caustic embrittlement in boilers. If hydrochloric acid is used, slight variation in the acid injection If it is higher also, acid concentration will not affect the resin bed. But in the co-current regeneration or counter-current regeneration, if sulfuric acid is used, correct concentration is to be used. Even very slight increase in concentration will lead to sulfate coating over the resin bed. It will follow by pressurization of the unit and that will lead to breakage of resin. So more fines will be formed unless we have close monitoring of sulfuric acid concentration, whether it is 3 or 3.5%, should be maintained throughout the regeneration. Then only we can avoid the pressurization of the bed. Then the fourth reason is iron fouling will not occur if HCl is used. If there is any iron present in the inlet water, then that will form fouling. If HCl is used as a regenerant, that fouling will not be there in the SH unit. If HSFR is used, then we cannot avoid the iron fouling. Once in a year or in specified time, acid soaking is required with HCl. HCl acid soaking is given to avoid iron fouling if HSFR is used as regenerant. Due to the formation of the insoluble ferrous salt and that will block the resin pores in the SAC bed. So iron fouling is to be removed by means of HCl soaking only, which will not occur if HCl is used in the regeneration. And the final reason is final treated water, the SBA outlet DM water conductivity is very less compared to SAC regenerated with sulfuric acid as injection media. If conductivity of DM water will be higher than the HCl injection bed, if HSO is used, conductivity will be little bit higher than the SAC used with HCl. The SAC outlet cationic water, which is acidic in nature, the pH of 2.5 to 3.5, and is sent to weak base anion. The resin form is RNH3OH. The WBA will absorb or remove chlorides and sulfates only. It will not remove carbonates and silicates, which in turn it will reduce the SBA load. WBA outlet water pH will be between 3.5 to 5 and conductivity also is considerably less compared to cationic water. Conductivity also will get reduced almost to less than 100 microsiemens per centimeter or micromole per centimeter, and chlorate's value also will be less than 10 ppm. WBA can be regenerated with sodium carbonate or with ammonia or with sodium hydroxide. If SBA and WBA are together, then it should be regenerated in Thoroughfare method. That is, SBA injection outlet will comes to WBA and both will be regenerated simultaneously. In Thoroughfare method only SBA and WBA are regenerated. 5% hydroxide, sodium hydroxide is used for SBA and 2% normally used for WBA. RNHCOH, the reaction is combined with the HCl weak hydrochloric acid from the cationic outlet water. It will get attached to the resin bed and water will come to next unit, degasser unit. Same as sulfuric acid, weak sulfuric acid also will get attached to the bed and water will be slightly alkaline. Chloride and sulfate and attached to the bed and regenerated along with the SBA. 2% NaOH used and the bed will become normal or NaCOH, and the regenerant effluent is sodium chloride and sodium sulfate, which is going to the drain. The WBA outlet water, which is coming to the degasser tower DGT, where carbon dioxide is removed by means of low pressure air. Mild pressure air blower is used to remove the weak carbonic acid. When air is admitted from the bottom, water is flown from the degasser tower top and CO2 is getting liberated. Normally, carbon dioxide is reduced from 100 to 150 ppm to less than 10 ppm. This weak carbon dioxide is coming from sodium bicarbonate, calcium bicarbonate, and magnesium bicarbonate. Calcium and magnesium bicarbonate gives temporary hardness, and sodium bicarbonate also will give alkalinity. All three will give bicarbonic acid, which is getting removed in the degasser tower itself. It will reduce the load of the SBA. The outer water is then pumped to SBA for further purification. As the degasser tower degassed water is collected at the degasser tower bottom sump. So we have to use the pump for SBA service. This is the schematic diagram of SH generation by means of countercurrent and co-current. Now we can see the countercurrent method. This is the cation inlet line from ACF. This is a backwash inlet line. This is the backwash outlet line. This is the injection header outlet line. And this is the service outlet line, which is going to WBA. And this is the regenerant final rinse outlet line. And this is the injection outlet line. Normally, this is the bed packing. Above this into mark, this is the inert resin. If resin bed volume is more and resin is used as inert resin. Or otherwise, we can use contract ball, which will be in suspension or mixed with the resin, which is inert, so it will not react with the water during service. So this inert resin will play a vital role during the regeneration. When the regeneration is given from the bottom, we have to keep downflow water or air. Normally water is preferred, so water is first set as downflow to be taken from the regenerant outlet header. This is the drain. Water downflow is maintained. That will keep the inert contact ball or inert resin intact. It will compress the resin volume, resin bed. So when HCl or H2SO4 is injected from the bottom, that will tend to raise the resin bed, which will be compressed by the inert resin, and over that downflow water also is there. So the intact of the inert resin by means of water, downflow water, will keep the injection residential area and area of contact is increased. So the bottommost layer is regenerated very effectively. Sodium slip is avoided thereby. So we'll get very pure water in countercurrent regeneration, and conductivity also will be less. But once in 5 or once in 7 regeneration, we have to give backwash. So during that time, when backwash is given, that means that inert resin over the bed normally which will not get regenerated during acid injection. Acid is kept as inert, and downflow water is also always coming. So the bed volume below this inert resin only will get regenerated. So for every fifth or seventh regeneration, when backwash is given, we need to regenerate the inert resin which get mixed with the normal service bed resin. So we have to use twice the volume of the acid or regenerant used, whether it is HCl or HSO4. So normal quantity is doubled for the every fifth or seventh generation. Then the final rinse is given, that is taken out here, and as usual we have to check the FMEA. When the FMEA becomes equal to EMEA, then the regeneration is taken as completed, and we can go for keeping the bed as standby. For the co-current regeneration, this is an as usual normal inlet line, and this is a backwash line, and this is a backwash outlet line, and this is acid injection line, this is the air vent, and this is the drain outlet, and this is service outlet. During the co-current, it is same as service is from top to bottom. For every regeneration, as first step is backwash, bottom to top, backwash outlet is there. After loosening the bed, whatever suspended or foreign material or fines present in the bed will be removed by means of backwash. Then it is followed by the 5% HCl or 3 to 3.5% sulfuric acid from top to bottom, and regenerate is taken out during this drain line. After injection is completed, we have to use the inlet water for final rinse, and that also drained out during with the drain line. And if the FMEA equal to service FMEA or if it's equal to the EMEA, Then regeneration is taken as completed and it is stopped. This outlet is going to the WBA. This is the co-current regeneration and this is the counter-current regeneration. The resin bed volume here will be less compared to the counter-current regeneration bed. If it is inert resin is used, the volume will be more, and if it is, you can use contact ball also. If contact ball is used, then the resin volume will be same, but the contact ball density should be less than water, maybe around zero point 0.8 to zero point 0.9 gram per cc. So counter current regeneration is preferred over the co-current regeneration because there won't be any sodium slip compared to this co-current, as the topmost layer is regenerated completely, but there will be some slippage in the from the bottom layer. So that will lead to high pH and high conductivity in the SBA outlet water. Also, the sodium slip will cause the caustic embrittlement in the boiler. Hope you might have understand the SCA service and regeneration and WBA service equations. We will see the WBA regeneration along with SBA service and regeneration in the coming episode. Do not forget to subscribe, share, or give your likes. Thank you very much.